Identifying a function. Okay, the first thing we have to do is go over a little bit of vocabulary. The very first part of the vocabulary that we need to review or go over. It says a mathematical relation exists when two mathematical values are related in some way. This word right here, relation, is the set of any set of ordered pairs. Okay, any set. So if you have a whole bunch of ordered pairs, then you have what is called a relation. The input value of the relation are the set of x coordinates. The output is the set of y coordinates. Okay, so if I look at these are all relations right here. Actually, you know what I'm going to do? I'm going to change this a little bit and make this, oops, I did not mean to do that. I am going to highlight this in a different color. Okay, so, sorry about that. So I am going to look at my x values. So all of those are the input values. These are the input values. These are the input values. Now, it's hard to tell with this, but the x value right here, the x value right here, okay, it's hard to tell with this because if you had written it as ordered pairs, it would be easier to see. Then my y values are my output values. These are my output values. Okay, there would have been an output here, an output here, an output here, and an output here. So those y values are your output values. Now, here's our next vocabulary word. Our next vocabulary word is a function. And it's a specific type of relation that assigns exactly one output to each input value. So let's look at this. By the way, this is called mapping. I forgot to look over those words a minute ago. So if I look at this right here, I know we've never seen this. This is mapping. And so if I was to write this as an ordered pair, -2, it goes down here to 3. So the ordered pair would be -2, 3. The next one, it would be 0, and 0 is going up to -1. Then 1 is going to 2. And then last but not least, the 3 is going to 1. Now, some people ask, how do I know that this column is the input and the other is the output? Look at the arrows. Okay, I'm going to actually erase what I did here. Do you notice that the arrow is on this side? So it starts here and it goes this way. So since you're starting at 0 or you're starting at -2 and you're going this direction, wherever your start is the input, that's what you put into it, and you get out 3. Or you get out whichever number. So when I look at this, and I have the input and the outputs, this first one says it's a function. Sorry, I'm trying to, let's do this. There we go. It says this is a function because each value is paired with exactly one output value. See how 2 only goes to one value. 4 only goes to 3. 5 only goes to 4. 9 only goes to 7. Okay, so there's exactly one output for the input value. Okay, if I look over here on the other hand, notice how 2 is going to 2 different numbers. That means it's not a function. This is not a function because 2 in the input is paired with 2 output values, 1 and 3. Okay? So if I'm looking at mapping, the arrow can only go from one input or X value to one output. So that means that it is not a function if there are 2 arrows going from one input to 2 different outputs. Outputs. Okay? So let's look down here. If I look at this, the mapping diagram labeled not a function shows the input value blank is mapped to both 3 and 5. So looking over here on the not a function, which one is mapped to both 3 and 5? Well, if I look at it, 1 is going to both 3 and 5. Because the input is mapped to more than one output, it is not a function. Okay, so let's come down here. Is this a function or not? Okay, so in order to decide whether this is a function, the input values, these values right here, can only go to one output. And if you notice here, 1 is going to 2 different things. So this is not a function, okay? This is not a function. So the relationship is not a function because the input value of 1 is mapped to more than one output value, okay? So let's look here. If I look at these if I look at these right here, 2 is going to -1. 4, though, look at that. It's going to 2 different things. So that means this is not a function because 4 is mapped to 2 different outputs, -5 and -7. Okay, right here. Now, if I'm looking at tables, so if I'm looking at a table, tables can be used to represent relations and functions. To determine whether the relation in the table is a function, consider how many members of the input correspond to the members of the output. So let's look at this. Okay, so right now, these are my input values. These are my input values. Compare these two. The first one, input, is 1, 2, 3, 4. The not a function is 1133. If I look at the function part, it says this is a function because each member of the input, so all of these values, correspond to only one. One is not repeated. Whereas here, this is not a function because the members of the input correspond to more than one member of the output. Look at this. The number 1 goes to two different things. The number 1 goes to 2 and 4. And then 3, again, goes to two different things. So it goes to both 6 and 8. So they are not. That is not a function. Okay, so if I have a table, the x values cannot repeat. So if I look at this, do any of these x values repeat themselves? No, they don't. Yes, the y value does, but it didn't say that the output couldn't be the same number. It says that the input or the x value, x, not y, okay, the x can repeat, but the y cannot. Are any of the x values that correspond to more than one output? No. The relation is a function because the input value corresponds to exactly one output. Okay. Do any of these numbers repeat themselves? Yes, 2 does. 2 goes to 3 and to 4. Those are two different numbers that it goes to. So it is not a function. Not a function because the input 2 goes to two different outputs, 3 and 4. Okay, then this is the one I really like. The ordered pairs of a relation can be graphed on the coordinate plane. So we have a coordinate plane. To determine whether the relationship on the graph is a function, you can apply what is called the vertical line test. Okay, remember, vertical lines go this way. If for each x value a vertical line passes through no more than one point on the graph, then the graph represents a function. If the line passes through more than one point on the graph, it is not a function. So, sometimes it's called the pencil test. So basically what it's doing is you're going to take a pencil and you're going to move it from left to right across and see if your pencil hits it more than once. And obviously with this video I can't actually move it, so I'm just going to draw vertical lines. As I draw these vertical lines, does this ever hit the line more than once? Okay, so for a vertical line test, as you move, that's an interesting way to spell that. As you move your pencil vertically, or I shouldn't say, as you move your pencil, does the pencil hit more than 1 point at a time? No, then it's a function. Yes, then it's not a function. Okay. The graph is a function because the vertical line test shows that it always intersects the graph in exactly 1 point. This means that each endpoint corresponds to one output. This is the most important phrase if you hadn't noticed yet. So this one, as soon as I draw a vertical line right here, this hits the graph in this spot and in this spot. So that is not a function because the vertical line test shows that it intersects the graph in more than 1 point. This means that the input corresponds to more than one output. Okay, so let's look at this one. Okay. Oops, I meant to do highlighter. As I'm drawing this, this is not hitting it in more than one spot. So the graph is a function because the vertical line shows that it always intersects the graph in exactly 1 point, and this means that each x, or each input, corresponds to exactly one output. So this time, yeah, the points are different, or the points are not connected to each other, but look at this. If I go like that, did it hit more than once? Nope. Did it hit more than once? Nope. Here. Oh, look at that. It hit up here. I should make these. It hit here and it hit here. So that means that it is not a function. The relationship is not a function because the input, the number 2, corresponds to more than one output. Because this would be the point 2, -3. This would be the point 2, 3. The input value of 2 goes to 2 different output values. So let's try it here. So I go here, 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 here. Okay? It doesn't hit more than once. So this is a function. Each vertical line only hits 1 point at a time. Oops. Okay. Here we go. Determine whether the relation is in the graph is a function. Use the vertical line test. Again, if I'm drawing vertical lines, use the vertical line test on the graph. Does the vertical line ever pass through more than 1 point? No. The relation is a function because each input corresponds to exactly one output. Then let's do this one. Passing, passing, passing. Oh, not passing. This is not a function the vertical line goes through more than one point at a time. Here, here, or here, here, and here. Okay? Awesome.